This is page 90 of your math journal. We're going to call this one Inequalities. Okay, let's write the definition first. An inequality compares two quantities. A mathematical statement that compares two quantities. Okay, there are 4 ways we can make an inequality. I want you to take and split your page into fourths, about 5 lines worth. 1, 2, 3, 4, 5. Split it here, and split it here. We're kind of making a table. Okay, first I want you to draw this symbol. I want you to draw this symbol here. This symbol, and this symbol. Alright, this first symbol is called less than. Okay, some other words that might be used here. Fewer than. Let's see, something else you might hear here might be I can't think of any others at the moment. This one right here is greater than. Meaning that this is greater than this one. Here I was meaning that this is less than this one. Another one that you might hear is more than. In excess of. This one right here might be below. That's another word. Oh, farther than. Okay, all of those wording might indicate that you're using those. Okay, now these ones, this is greater than or equal to. That's what this little line right here means. It can be equal, but it can also be, oh, I said that wrong. This is why you should do your thing in pencil. Less than or equal to. So we're saying that this is less than or equal to this. So the difference is here, it could be equal, but it could also be smaller. Some other wording you might use is at most. No more than. All these wording are saying it could be equal, but it could also be smaller. This one here is greater than or equal to. Some other wordings that might be used is at least. Or no less than. Okay, these wordings are going to be super helpful to you. So example where you might use each one of these. 3 is less than 5. Here you might say 5 is greater than 3. 7 is less than or equal to 10. 12 is greater than or equal to 7. So here it could be bigger, it could be less than, it could also be equal. So I could put a 7 here and still make this true. So we could do 7 is greater than or is less than or equal to 7. Here I cannot do 5 is greater than 5 because it doesn't work. Here I could also say that 12 is greater than or equal to 12. But here they can't be equal. And that's the difference between this one, these two, and these two. Alright, let's try another star, and we're going to write what a solution is. A solution makes a mathematical statement true. Okay, kind of like with our equations, when we plugged it in, if it made it a true statement, it was a solution. Well, here, I want you to write in big stars, inequalities have more than one solution. Okay, knowing that, oh, I need to scoot my thing down, I'm sorry. So a solution makes a mathematical statement true, and inequalities have more than one correct solution. So when we have an inequality with a variable in it, there could be more than one number that actually makes it correct. So let's do some examples. Which of the following numbers makes each inequality true? Following numbers are solutions to the inequalities. Okay, let's do 3, 7, 11, 10, 6, 14, and 100. So, we're going to look at two different inequalities, and we're going to test which ones make these inequalities true. So the first inequality will be f plus 4 is greater than 14. The other inequality we're going to do is 2n is less than or equal to 60. I'm sorry, 12n is what I meant to put. Okay, so plug in what we have. First one, 3 plus 4, is that bigger than 14? No. So 3 is not a solution. Try 7. 7 plus 4 is bigger than 14. No, 7 plus 4 is 11. So 7 is not a solution. If we plug in 11, 11 plus 4 bigger than 14. Yes, this is worth 15. So 11 does work. So yes, 11 is the solution. Okay, let's try 10. 10 plus 4 is bigger than 14. If this had an equals under it, it would be true. But it doesn't. So this is not a solution because 14 is not bigger than 14. I'm changing something around just a little bit. We're going to make this a 5. Okay, so let's put in 5. 5 plus 4 is bigger than 14. Nope. 14 plus 4 bigger than 14. Yes, I'd give me 18. So 14 is a solution of what we've been given. Try 100. 100 plus 14 is most definitely bigger than 14. Sorry, bigger. We're adding 4. 104 is bigger than 14. So yes, 100 is also a solution. Okay, here, what's happening? This is 12 times n. So 12 times 3 bigger than or equal to 60. No, 12 times 3 is 36. 36 is not... Oh, I'm sorry. I lied on this one. 36. I've got to look at this. The mouth is facing bigger towards the 60. Is 36 less than or equal to 60? Yes. So this is a solution. Let's try 7. 12 times 7 is 84. 84 is less than or equal to 60. 84, I'm sorry, 84 is not less than or equal to 60. So, no, this is not a solution. Let's try 11. 12 times 11. That's 132. 132 is not less than or equal to 60. So, no. So 12 times 10 less than or equal to 60. That'd be 120. 120 is not less than or equal to 60. So 10 is not a solution. 12 times 5 is less than or equal to 60. Well, 12 times 5 is 60. 60 is less than, or it's not less than, but it is equal. And because of that equal right there, yes, this is a solution. Okay, 12 times 14. I don't know what that is right off the top of my head. 44. Sorry, I'm doing some math over here on the other paper. 168. 168 is definitely not less than 60, so no. And 100, 12 times 100 would be 1,200, and that is definitely not smaller than or equal to 60, so once again that is a no. But now you know how to check and see if things are solutions to inequalities.